Hello students, today we'll solve one beautiful problem from CSIR NET 2017 December, and obviously this question is from particle physics. Okay, so in that question they have asked which decay is not allowed by strong interaction but allowed by weak interaction. So to solve this question we'll apply that conservation of quantum numbers. Okay, so we'll check one by one. So decay A, P plus N decays to D plus P bar. That D means down quark. Okay, so let us check that charge conservation. So for P, charge is +1. For N, charge is 0. For D, charge is -1/3. And for P, again charge is +1. And for P bar, charge is -1. So you see, charge is not conserved because on the left hand side you have +1, but on the right hand side you have -1/3. Right, so charge is not conserved, that's why this decay is not allowed. So it is not allowed by any interaction. Okay, now we'll check decay B, that is delta plus K0 decays to P plus N. So let us check charge conservation first. So for delta plus, charge is +1. For K0, charge is 0. And for P, charge is +1. For N, charge is 0. So charge is conserved in this decay. Okay, now we'll check lepton conservation. So none of them are lepton particles, so obviously that number will be 0 for all. So this implies lepton is conserved for this decay. Now we'll check baryon conservation B. So delta plus is baryon particle, obviously this number will be 1. For K0, this number will be 0. Since this particle is meson, so that's why this number will be 0. And for proton, this number is +1. And again for neutron, this number will be +1. So on the left hand side you have +1, but on the right hand side you have 2. It means baryon is not conserved in this decay. That's why this decay is not allowed by any interaction. Now we'll check decay C, that is P plus delta plus goes to N bar plus delta double plus. So we'll check charge conservation. So for P, charge is +1. For delta plus, charge is +1. For N bar, charge will be 0. For delta double plus, charge will be 2, right? Since it is double plus. Okay, so charge is conserved. Now we'll check lepton conservation. So none of them are lepton particles, so obviously this number will be 0 for all. So it means lepton is conserved in this decay. Okay, now we'll check baryon conservation. So proton is baryon particle, obviously this number will be +1. And same is true for delta plus, this will be +1. N bar is anti-baryon, so that's why this number will be -1. And for delta double plus, this is also baryon particle, so that's why this number will be 1. So on the right hand side, this number is summation of this number is 0, but on the left hand side this number is +2. So again baryon is not conserved for this decay, that's why this decay is not allowed. Now we'll check decay D, that is K0 plus pi 0 goes to K0 bar plus pi plus plus pi minus. Okay, so let us check charge conservation. So for K0, this number will be 0. For pi 0, again this number will be 0. For K0 bar, this number will be 0. For pi plus, it is +1. And for pi minus, it is -1. So it means charge is conserved. Now we'll check lepton conservation. So you see none of them are lepton particles. So obviously this number is 0 for all. Which implies L is conserved. Now we'll check baryon conservation. Again, none of them are baryon particles, so this number will be 0 for all. Okay, so baryon is conserved for this decay. Now we'll check isospin. So for K0, the isospin is a half, and for pi0, isospin is on. For K0 bar, isospin is again half, because for antiparticle, the sign of isospin is not changed. Again for pi plus, that value is plus on. For pi minus, this value is plus on. So you see, isospin is not conserved in this decay. Now we'll check third component of isospin. So we'll check this. Here we'll check third component of isospin. So for K0, this number is minus half. For pi 0, this number will be 0. For K0 bar, this number will be plus half. For pi plus, this number is on. For pi minus, this number is minus 1. Okay. So we see this I3 is not conserved here. Now we'll check strangeness is. So K0 is strange particle. So obviously this number is plus 1. For pi 0, this is 0. For K0 bar, S is minus 1. And for pi plus and pi minus, this number is 0. So on the left hand side, S is plus 1, but on the right hand side, S is minus 1. It means S is also not conserved. So it means this decay is allowed with weak interaction, but not allowed with strong interaction. So correct option is D. Thank you.